Hello everybody. So today I will talk about calculus. The topic today is about triple integrals. So now I will show you how to answer. We have E is the region between the spheres, this one and this one, inside this one. So now I will show you how to answer. If we wrap this function in here, the graph should be like this. Here is about the graph of three equations. If we look carefully on the figure, we see that we have the blue. That's about the cone in here, the blue in here. The red is about the sphere with the radius is about number 2. The square root of number 4 is about number 2. The square root of number 25, we have number 5. So this is the big sphere and the small sphere in here. The question they want to find the region between the sphere inside of this one. So if we look carefully inside of this one, that is about the cone in here. And we know that they between two spheres, that is this area in here. Because if we zoom out a little bit, the cone will be go outside the small sphere and inside the big sphere in here. So this is the area we need to concentrate. Now we put inside the bounds in here. We have 3 bounds. So we have z square we put in here. The first thing that's about dz. If we look carefully, we have inside this one. So inside, that means from 0 to this, the function in here. So they start from the negative, because negative is about the bottom and number 0 should be in here. Now we go to dy. So in this situation, after we finish dz, we move to dy. About dy, so in this situation, z equals to number 0. So we just have only s square, y square, s square, y square. So if we look carefully about this one, they go between two spheres in here. The small sphere, they go inside the big sphere. So in this situation, we have s square plus y square equal to number 4. S square plus y square equal to number 25. So they between the sphere in here. The small one should be go in here. So we have s square plus y square equals to number 4. So we put s square go to the right. Later that we put the square root for the both sides. Similar for the next one, we do the same with number 25. So about dy, they should be between about 4 minus s square to this one, number 25 minus s square. The last one, that's about the s. So in this situation, s equals to, y equals to number 0, because we just finished about dy. So we have number 4 and number 5. So that should be between about number 2 and number 5. We know that this is about positive. So we just concentrate about positive. Now we go to negative. So we keep about this one, but we just put about the negative in here. So because negative, this one is smaller than this one. And number 5, negative number 5 is smaller than number 2. Because from number 2 to negative number 2, they will set up at the same. So if we combine two another intervals, we can add another from 0 to number 2 and from 0 to negative number 2. So in this situation, I will change number 2 into negative number 5. Because number 5 is about the highest radius of this one. Now we change number 2 into number 5. Now we just finished about the setup. This is positive number 5. So after we finish about the set of triple intervals, we need to calculate about this one. So I will calculate this integration. So we have z square in here, so we will have z to the power of 3 over number 3, and we have the bounds from 0 to this one in here, and we have dy dx. So we put the bound go in here, this one go in here, so we simplify. And we will have about 1 over 3 s squared plus 1 over 3 y squared to the power of 3 over 2. The square root is about 1 over 2. The power 3 in here, that's why we have 3 over 2 over number 3 dy dx. We do similar for the second one. So in this situation, this is about the circle, so we can use about polar coordinates. So I will put about s equals to r cosine theta, y equal to r sine theta. About dy dx, we change for r dr d theta, s square plus y square equal to r square. So we know that we can combine two integrals in here. S square plus y square we change for r square, so we have 1 over 3 r square to the power of 3 over 2 over 3 dy dx we change for r dr d theta. About the bounds of r, we see that they between the radius number 2 to the radius number 5. So r in this situation, that should be from number 2 to number 5. The next one, we see that we go one circle in here around one circle. So we put about from 0 to 2p. And this is the technique to combine two triple integrals in here. Now we need to calculate about this integration. So we have 1 over 3 to the power of 3 over 2. R squared to the power of 3 over 2, we have r to the power of 3 over number 3, and we have r dr d theta. So 1 over 3 to the power of 3 over 2 and number 3 I will put outside, and that should be about 1 over 3 to the power of 5 over 2, because number 3 in here is about number 1. 3 over 2 plus 1, we have 5 over 2. This one we have r to the power of 4 dr d theta. The integration of r to the power of 4, we have r to the power of 5 over 5. And we have the powers from number 2 to number 5. We put number 5 going here, number 2 going here. So we have 3093 over 5. About the theta, that is so simple right now. So I will put 2b minus 0. So we combine everything and we have the final answer.